Good evening, all.
Good evening, sir.
Right, okay. Today we have to explore more about, we just finished the database section, and so there are some minor parts, right, like the normalization part, so we have to go through that. So then after that we have this part, actually ER diagrams. We have discussed how to draw ER diagrams and all. So basically we have to discuss database normalizing, and my expectation is to discuss that with a question. So because it's a very easy topic, and we have already done some discussions related to that in the paper discussion class as well. But if you have like so any difficulties, I would like to remind it again with some paper discussion. Actually normalizing means like, so I'll just summarize. So normalizing means when before we create in the tables, before we create in databases and the database tables, we have to make sure that anomalies or the issues are not happening. So there are three kinds of anomalies in the tables, databases. So the anomaly number one is insertion anomaly. Then there's another anomaly called deletion anomaly and updation anomaly. So those are the anomalies that you face in databases. To avoid these anomalies, right, to avoid these issues, you have something called normalization. So it's a very simple concept, so very easy to remember that. Let me summarize it quickly. So let's say you have a table, so a set of tables, and the first thing that is like concern is having a primary key. So that, you know, we have already discussed, that is a unique identifier. So if there is a unique identifier, and also the values are atomic. Atomic means in single cell, so you can only keep one value. It is not possible to keep multiple values in single cells. Single cell, only single value. So then we call atomic values. Single cell, only a single value or atomic value. And also the next thing is, so you have a defined primary key as the unique identifier. Then we call the database or the tables are in the first normalized form. So that is too easy. Atomic values and no multiple values. That means, let's say here in the telephone number column, it is not possible to have two telephone numbers. Only one telephone number. So if there are two telephone numbers here, then so it is not in first normalized form. Because when you know that if you want to update one telephone number, there is no method, because you have to update both telephone numbers to get one update, because it is in the single cell. The smallest unit in the database is cell. So it is intersection of the row and column. So if you want to update this cell, so it is not possible to update part of the cell, only possible to update the cell. So therefore, so insert the updation anomaly will occur. So if you want to delete single data, again the problem is there are two items, then it is not possible to delete single. So because when you try to delete single one, it will delete both. So that is deletion anomaly. And insertion anomaly means if you try to insert this multiple values in single cell, you have to give as a single value. That is also a problem. So insertion, deletion, updation anomalies are there. So once the first normalized form is solved, the second thing that you have to consider is the second normalization form, or 2NF, or the second normalized form. Actually, issue comes with the second normalized form is called partial dependency. Right? So we have to know about, we should study about the partial dependency. Partial dependency is where you have a composite primary key, that means combined primary key. Here you can see this is not atomic value. This table is not in first normalized form, right? So if you want to make it in first normalized form, you have to break into two tables. You can see the ID and the name in one table, and then the ID and telephone number is in another table. So telephone number is the unique identifier, and the ID will become the foreign key. So this is how you make it into the first normalized form. Then the second normalized form. Quick example, you can see here teacher ID, department ID together creating the primary key. This is composite primary key. 2 keys. We learned this last day. 2 keys together created the composite primary key. Keys දෙකක් එකතු වෙලා primary key එකක් හදන වෙලාවට තමයි මේ 2NF බලන්න ඕනේ. නැත්නම් 2NF බලන්න ඕනේ. If the table is in first NF, 1NF, then mostly the table number 2, the table will be there in the 2NF as well. අතන 1NF තියෙනවා නම් 2NF උත් තියෙනවා. ඒක sure. හේතුව, so if you don't have a composite primary key, you don't want to worry about this what you call the transitive, partial dependencies. Partial dependencies where you can see department name is depend on department ID. The department ID එක මත department name එක රඳා පවතින නැත්නම් අනිත් පැත්තට අපිට කියන්න පුළුවන් department name එක මත ID එක. ඕ ID එක මත name එක. ඔන්න ඕවා partial dependencies. Partial dependencies කියන්නේ හේතුව තමයි why it is called partial dependency, because department ID is part of the primary key. Primary key එකේ part එකක්. So if some key, if a non key is depend on part of the primary key, that is called partial dependency, then that is a violation of 2NF. Therefore, this table is not in 2NF. ඇත්තටම මම summarize කරන්න ගියට මම හිතන්නේ මම ඔක්කොම කියලා දෙනවා. Right? එතකොට 2NF නැති වෙන්න හේතුව මොකද්ද? 2NF බලන්නේ මොන වෙලාවටද? When there is a composite primary key. The 2NF නැති වෙන්නේ if there is a partial dependency, that means key එකක් නොවන එකක් key එකේ භාගයක් මත depend. Key එකක් නොවන එකක් key එකේ භාගයක්, half or the part of the primary key. If a non-key is depend on part of the primary key, that is called partial dependency. If there is a partial dependency, then table is not in 2NF. How to normalize back? So you have to divide teacher ID, teacher name, one table, department ID, department name, another table. And teacher department to combine it. Combine it, teacher ID එකට teacher name එක දාන්න. Department ID එකට department name එක දාන්න. Assign with your teachers la බලන්න. You have a teacher department table. There you have teacher ID, department ID both, and the join date you can put there. Okay, that is how the second normalized thing, or the I'll give you a chance to write these examples in your book, right? So then you can easily remember this stuff by referring to the examples, and it is where the 2NF comes, and this is where 2NF violates, and this is where the 2NF assured again, back again. Then because if it is in non-normalized form, you have to normalize it back. Otherwise, so your database is not really good. It is having insertion, deletion, and updation anomalies. That's why we are putting this to, we are normalizing this back. Third thing, 3NF. This is the final thing that you need to know under the syllabus. So of databases. 3NF. 3NF means it's something like this. You can see the postal code is depending on the city, and city is depending on the postal code, whatever you say. So this city is not a key. Postal code is also not a key. If non-key is depending on a non-key. Primary key වලට අදාළ නැහැ. But there is a non-key which is depending on some other non-key. If non-key depend on non-key, then it is called transitive dependency. Key එකක් නොවන කෙනෙක් key එකක් නොවන කෙනෙක් මත රඳා පවතිනවා. That is called transitive dependency. If there is a transitive dependency, let's say you update Gampaha to K-goal, then you have to update K-goal and postal code both. So that is the insertion anomaly or the updation anomaly. If you want to delete postal code, you have to delete the city as well. The city and postal code related. So it is deletion anomaly. So likewise, so there are anomalies when there is a transitive dependency. The solution is postal code and city in one table, teacher ID, teacher name, and the city or the postal code is in one table. So postal code here is the primary key, which will be there as the foreign key. So this is how you assure the normalized form for 3NF. Okay, that's it. Only 5-minute lesson. So very simple, 5-minute lesson, small lesson. So that is about the normal. But most of the students feel discomfort or feel, so they think it is difficult to learn. They think it is difficult to study about this normalizing. The reason is, so they are not really capturing the They are not really understanding the theory part. Okay, you can take a screenshot of this. I'll give you a chance. Okay, see here. So this is violation of 1NF, non-atomic values. So table is not, is it in 1NF? No, table is not in 1NF. So because it is a violation, how you normalize? Okay, take a screenshot of this. Later you can write down. Then here, this is how to fix it.
So can you show the previous slide again?
Yeah, sure. So this is 1NF violation because you can see values are not atomic. Values are not atomic, not single, not atomic. That's why it's violated. Okay. So then this is the fix. This is the fix. This is violation of 2NF, where you can see a partial dependency. Violation of 2NF. Partial dependency arise. This is the fix. When there's a partial dependency, you have to break down into two tables. Sorry, here actually you have to break down into three tables and combine that using one another table. So this is the fix for 2NF issue. This is a violation of 3NF. Transitive dependencies. And this is the fix. This is the fix. Okay, that's it. So let's move to the next part of your syllabus today. So now we came up with some. Okay, so with that, the database particular part is over, and let's move to the next one. And competency 11 here. So this is about the digital systems, and so this lesson, so this you will get some small questions, like only few marks in these questions, but in order to finish the syllabus, we need to finish these lessons too. So microprocessor development boards or development systems. So basically, you know that in this world, today's world, almost all the devices are connected. Not only the people, even animals are connected. So this is, you can see RFID tracking for pet. So if there is a dog or cat, so people use RFID tracking. or radio frequency ID tracking. So just to identify pets and cattle, here you can see. To identify them, so we are using small radio frequency IDs with some component, even to here animal tracking. So cattle and these in animal farms, to track them, so these RFID systems are used. RFID tags, RFID tracking or RFID tags are used to identify them, to identify the animals, dog, cat, even so in animal husbandry. So when there are animal farms, these devices are used. So it is possible to use. I think you know about Google Home. Google Home. So what they came up with, Google Home, basically there's a component enabling voice command. You can connect most of the appliances to this device and control centrally manage them. And you can automate your home using Google Home. Basically, I think you know the lights, right? It is possible to have Wi-Fi enabled switchboards. While Wi-Fi enables switchboard, these are called smart switches, right? Wall switch, let's say wall switch, otherwise you will not get that. Wi-Fi enabled or smart switches. So these smart switches can be connected to your mobile phone. The smart switches can be connected to your mobile phone. So after connecting that, you can control them using your mobile phone. You can just issue a command to turn on or turn off it. Based on your requirement, you can configure. You can set timers. So you can turn on auto on and auto off. So this is home automation. When there are vehicles, inside the vehicles also, inside the vehicle, inside the washing machine, you know, smart refrigerator. Smart refrigerator is a fridge which has internet access, not to access Facebook basically, but to configure the refrigerator. There are smart washing machines. Right, this is smart washing machine. You can just connect your mobile phone to washing machine and control this. Even you are not there in your home, it is possible to automate and control. Even some countries, so where you have like issues like this, there are sudden temperature drops in some other countries. When the sudden temperature drop happens, so there will be ice in your door, window, maybe even in your washroom. So when you want to access the washroom immediately, but due to this ice, you have to wait until it melts. So that is a headache. But being at home, if there is a sudden drop, so you will get the news. And being at home, you can control your washroom, your bathroom. You can control that using your mobile phone, set in the temperature, set in the heater zone. It is not possible to turn on heaters always. It is not possible to turn on heaters. It is not possible to basically keep heaters on, because you know the electricity consumes electricity. It is not possible to turn on ACs always. It also affecting the electricity usage. Therefore, you need smart control to your home and the environment. These things can be configured by connecting to. So have you seen these IP cameras? These are not CCTV. IP camera is a camera which can be directly connected to internet. This is not CCTV, right? It can be directly connected to internet. And if you have an IP address to your home, if you have purchased IP address to your home, it is possible to access this camera from anywhere in the world. It is possible to access these cameras anywhere from the world. Like So if you want to access public IP cameras, I'll give you a small trick. Just go to Google. So sometimes this is not working, but earlier days this was really working, but now there are a few. You can just search in URL :/index view/index.html. You search like that, there is a higher potentiality to get some IP cameras. Okay, these are some IP cameras. IP cameras means cameras which are directly connected to the internet. Without a computer, these cameras are connected to the internet. So anyone can access from anywhere in the world and view what is happening, what is going on. So see that I don't know this country, but you can just use the IP address to find out the country. So let's see, use IP to location. So when you use IP to location, you'll get this site and just paste your IP address that you want to browse. It's this IP, and I'm just searching, just looking up, and you can see, oh, sorry, it's wrong way of searching. I just want to put the IP address only, no need to have the protocol. Just put the IP address and search it. Let's look up. And when you search, you can see IP address belongs to Spain. Spain. So what is the time in Spain? So what is the time in Spain now? It is 3:18, January 15. The day is today. The time is 3:18, still 3 p.m. You can see the evidence here. Not this. I think this one. It's 3 p.m. right? It's 3 p.m. there. So if you want, you can just search as I said, and these cameras are live, right? These are not CCTV. These cameras are live. You can just, some cameras it's movable, but some cameras are password protected. Not working here. But this camera, I think, yeah, it's some other place. Yes, this. Can I zoom it? No, it's asking for some passwords. But some cameras, you can see accidentally they have not configured, so you can also move these cameras in that country. මෙහෙම move කරනකොට එහෙ කැමරා එක කරගෙනවා. Password දාලත් නැහැ. එහෙම අමතක වෙච්ච ඒවා එහෙම තියෙනවා. Just go and see. Okay, this is a pendulum. I think it's from DE, means sometimes Denmark, I'm not sure. Just you can just go and search this URL to whom this belongs to. You can use this IP to location feature. Okay, these are some examples, directly connected cameras. Okay, so likewise, there are different components. Even, have you seen smart watches? So this is now normal in Sri Lanka even. You can connect watch to the internet, and there are smart wallets. Sorry, smart wallet. Your wallet is connected to the internet. So why should you have smart wallet? Then it is discoverable, right? Or pickpocket ගහගෙන කවුරු හරි අරන් ගියොත් ඒක discoverable because that wallet is smart. So you have smart wallet and smart belt even. So you are discoverable using smart belt, right? And smart glasses or eyewear. Basically, these eyewear, these are having cameras. You can say these are having cameras on the display where you can access some components. Even you can see and identify these things, right? It is possible to use these glasses to identify, and you can see the date and time, all these things. And smart mirrors. I have even created a smart mirror. Okay, you can also give a try to create smart mirror, a touchable mirror. So it is possible to do it by yourself here, DIY smart mirror, to do it yourself, smart mirror. So these things are possible, right? All these things are done using some kind of boards called development boards. or development system boards. You can see. So here there are some features and also some description given about this. So let's learn about these development boards and how these boards are connected. And let's learn about how IoT applications work. It is a small chapter. So only two main topics. You need to know about what are these development boards and where the IoT is used. I said that IoT, Internet of Things, IoT, Internet of Things. There is something called IoET. That is called Internet of Everything. Internet of Things, Internet of Everything, IoET. IoT and IoET, Internet of Everything. So then about these development boards and their connectivity and how things are working, let's learn about this quickly. And also let's go through, so we'll learn about this part definition, what is IoT, Internet of Things, needs, applications, we learn about that, and embedding technologies, where it can be embedded, we learn about that as well. And so here, simple application to construct a remote switch. How can we create a remote switch to turn on and turn off something? So let's do these things now. Let's do these things practically to learn. So I can do this theoretically, then you won't be able to enjoy the lesson. Therefore, I'm going to do this using practical methods. To do that, I'm going to use small website, that is Tinkercad. If you don't know this website, so you need to create an account there. You can log in using your Gmail, that doesn't matter. Whatever method you prefer, you can use. It is tinkercad.com. Then you have small button here when you access this website, that is called Start Tinkering. Start Tinkering. Just click on that. Then in Smart Tinkering, so Start Tinkering, after that, please use create personal account, or you can use sign in. I'm going to use sign in because I already have an account. I'm going to use sign in. You can also do it because you can sign in with Google, right? Therefore, you can also use this sign in with your Google. After clicking sign in, just select sign in with Google. This is from Autodesk, one of the famous vendors who has developed Maya like tools, AutoCAD. Let me continue. You can use this for free. I hope everybody has created an account. You can use it for free. Okay, there are few things, 3D design, circuits, code blocks, lessons. I would like if you can use this one, circuits. And under that, you can click on create new circuit. Okay, after that, you will get this. Okay, so there are some development boards here today. So one is Microbit. Microbit actually you have in grade 9. If you have learned that, you had this in grade 9. Then comes Arduino. That is another board, another development board that we are going to test today. And another one is Raspberry Pi, but unfortunately that is not there in this place. Raspberry Pi, and so we can test Microbit and Arduino. but not Raspberry Pi. Raspberry Pi is another board. I'll explain that also because it is not there. Let me explain. So I have created a smart mirror using Raspberry. In Raspberry Pi, so the development board comes like this. Actually, this is small computer, Pute. This is small computer. It has processor. You can see this silver color one, and processor and a memory, and random access memory as well as the processor. You have these things in the board. So these USBs are for input and output. And you have RJ45 for network connectivity. And you have Wi-Fi module and Bluetooth, which can be used to connect to Wi-Fi or Bluetooth. You have a power jack to give 5 volt and charge it. This is only only using 5 volts, small, very small computer using very less amount of power. It has operating system also. It is possible to install the operating system into here. You can see, you can keep this in your hand. So how you insert your operating system? Pretty simple. You can use micro SD card. Micro SD card to put your operating system. See how simple that is here. You can see the connectivity. Here to this place, you are connecting the micro SD card. When you put the micro SD card, you can basically install an operating system to this micro SD card in this development board. And then after that, after giving the operating system, it is ready to connect. I'll give a few examples today. So please search in my channel. Please access my channel. And then you can go to here, click on. So after accessing the channel, that is, Learn ICT, Dasun, Nilanjana, Sirimevan, just go to videos and search there. You can search like, you can search by Raspberry. Then you will get this smart mirror, which I have developed using Raspberry. This is smart mirror, which I have developed or created using the Raspberry Pi 1. So this is it. You can see. You can see how it works. So this is from the mirror actually. From the mirror, I can see myself. This is how it looks like. Okay, let's see the connectivity.
Through my online store alone, we've sold over $500,000 worth of spices. That's so crazy.
Here you can see the sound, power, HDMI and sound, all these things. And then this side, micro SD card.
Install කරලා තියෙන්නේ. ඒක අපි වෙනම ටියුටෝරියල් එක කියලා. මුලින්ම මට අවශ්‍ය වෙනවා මේකට HDMI to VGA cable එක port එකට සම්බන්ධ කරගන්න. ඊළඟට මේ port එකේ අනිත් පැත්ත HDMI පැත්ත ඒක අපිට සම්බන්ධ කරගන්න පුළුවන් මෙන්න මේ port එකේ HDMI port එකට.
So you can see the HDMI connection and the VGA, which can be connected to a monitor then. After that, you can connect the keyboard and mouse. And here, this is how you can see the operating system after turning on this computer in a normal monitor. After that, I'm just modifying smart leaf pad again. Actually, I have obtained weather information from AccuWeather or a weather site. This is forecast basically. Darksky.net. That is where I have accessed the weather information. So darksky.net again, weather news අදදරන.lk එකෙන් ගත්තා නිවුස් මේ තියෙන්නේ. එතකොට ඔය දෙක අරගෙන here after connecting that හරි ඔය වගේ application එකක් තමයි
අප්ඩේට් වෙනවා ටයිම් එක දිගටම වෙනස් වෙනවා ඒ වගේම වෙදර් එකත් ඒ වෙලාවේ වෙදර් එක ටයිම් එක යටින් නිවුස් ටික අප්ඩේට් වෙනවා අලුත් නිවුස් එනකොට ඒකට එනවා දැන් අපිට කණ්ණාඩියෙන් මූණත් බලන්න පුළුවන් දැන් මේ තාම තියෙන්නේ මොනිටර් එක still it is there in the monitor ඒක වෙනස් වෙනකොට මේ අර වෙදර් ස්ටේෂන් එක හරහා ඒ API එකකින් අපිට හම්බ වෙන ඩීටේල්ස් හරහා වෙදර් එකත් වෙනස් වෙනවා මේකේ මැද්දේ ක්ලික් කරලා එන්ටර් කරන්න ඕන මේ තමයි අපේ ස්මාර්ට් මිරර් ඇප් එක හැබැයි මේක ස්මාර්ට් මිරර් එකක් වෙන්නේ නැහැ නේ තාම මේක හරි මේක එතකොට මිරර් එකක් වෙන්න නම් ඇක්ලිටික් මිරර් එකක් අපි ගන්න ඕන ඇක්ලිටික් මිරර් එකක් කියලා කියන්නේ මේ ඇප්ලිකේෂන් එකක් මම කියලා දෙන්නේ ඇක්ලිටික් මිරර් එකක් කියලා කියන්නේ අහලා තියෙනවද two way mirrors have you heard of two way mirrors or acrylic mirrors ඒ කියන්නේ ඒකෙත් පැත්තෙම පේනවා අර ඔය කියන්නේ ඔය මේවා වල එහෙම තියෙනවා ඩ්‍රෙස් රූම් වල එහෙම තියෙනවා ප්‍රයිමරි කියලා කට්ටිය බය වෙලා ඉන්නවා ඇක්ලිටික් මිරර් කියන්නේ මේ මිරර් එකෙන් ඔයාවත් පේනවා මිරර් එක අනිත් පැත්තෙන් කවුරු හරි බැලුවොත් ඒක වීදුරුවක් වගේ transparent උත් වෙනවා so this is this acrylic mirror I bought this from some other country මේකෙන් දැන් අපි වීඩියෝ කරන එක නවත් පේනවා ඇක්ලිටික් මිරර් එක තිබ්බ හැටි මාව පේනවා හොඳයි මේක මොකද්ද මේක අපි කියනවා two way mirror එකක් ඒ කියන්නේ මේ මිරර් එකේ ගොඩාක්ම ලං කරාම මේ මිරර් එකෙන් එහා පැත්ත දකින්න පුළුවන් ඒ වගේම මේක සාමාන්‍ය ඈතකින් තියෙද්දි ඔයාලට පේනවා මේ මිරර් එකෙන් අපිව පේනවා ඒ කියන්නේ මේකේ තියෙන විශේෂත්වය තමයි මේකෙන් ලයිට් ගමන් කරනවා 100ට ඉතා සුළු ප්‍රමාණයක් so basically 4% of the light travels through this mirror so the white color font can be seen in the monitor and if your monitor is having captive touch screen right if your monitor is having captive touch screen the mirror can be touched it is touch based mirror so these are some applications developed using these two way mirrors or acrylic mirrors this is touch based captive touch screen එකක් තිබ්බනම් අපිට touch based mirror එකක් විදියටත් පාවිච්චි කරන්න පුළුවන් ඉතින් okay these are the things you can experiment by yourself ඔයාලටත් පුළුවන් අනේ පරීක්ෂණයක් කරලා මේ වගේ දෙයක් කරන්න this I have done 2 years ago you can see in 2020 I have uploaded this to this as a project okay that's it that is about this Raspberry Pi and it has operating system called Raspbian and that operating system here so basically we can configure as we wish we can access internet that is special one and in this board today so there are you can see a lot of pins here in this board I think you have seen bus model there are some pins these pins are programmable these pins are programmable that means you can put inputs outputs you can capture input output through these pins okay that's it right let's come to our work and today we are going to develop the small circuit using this and so let's identify the interface now I hope you all open the Tinkercad interface have you done open this application today or not Tinkercad open karagattada I hope yes right okay
how to get this screen
sorry
how to get this yes.
so I have sent the link today didn't you receive that
I logged in but how to get this screen
this screen
yes
all right then you have to once you log in you have to select this here Tinkercad dashboard you have to select circuits can you see circuits there
yes sir.
okay in that circuit you have to click on create new circuit
Okay.
Create new circuit then you'll get that screen Okay. Right. Okay. Unfortunately or fortunately, right, I have to tell this. So no one else is doing this using simulation environment. I know that. So when I introduce this, after I introduce this, other teachers, so there are a lot of teachers watching my channel, YouTube channel. So they basically copy or imitate from that. So that is what happening. But the thing is that, so a lot of students are not given the opportunity to do this practically with the teacher and do some experiment with this. That is what happening in Sri Lanka. So unfortunately or fortunately, there are very few students trusting me, joining with my classes and learning this with this method. But if you are learning like this, you will never forget the stuff, and definitely you will go for a pass in your examination because you have experienced the subject, whereas the others just touch the subject. They see the subject and you experience it. Right? So other advantage is when just other students just pass the exam and you pass the life. They pass the exam and you pass the life. Why? When you learn things practically, you can apply it in your lifetime. So IT is a practical skill that you need to develop. So if you can apply this skill, and you can do a lot, you can achieve great heights, you can reach great heights. Okay, let's do this. So I'll take a coin battery, which is 3-volt coin battery. And then after that, I'll take another battery, which is 1.5 volt, generally AA battery. So if I try to connect LED bulb to this AA battery, what is the, so I have only one LED and I'm going to put yellow color to that LED. And here it is, you can see the yellow color LED now. So what is the plus edge and what is the minus edge? What is the plus edge and what is the minus edge? Yes, tell me. What is the plus? Plus is the longest, right? Anode is the longest one, right? You can see here. So let's erase that. Anode is the longest here. When you move your mouse pointer, you can see the anode. Just connect anode to the anode. Let's connect that to the positive edge. Then the cathode. Let's connect that to the negative edge. Round down on connect let's connect anode to the positive and cathode to the negative, and let's play this. Let's start the simulation, and you can see there's a small light, very light light coming through this bulb, and it actually 1.4 volt AA battery is not enough to power on LED bulb. That is the reason. AA battery LED bulb රුපියල් 2ක් වෙයි දැන්. මම දන්නේ ඉස්සර නම් රුපියල් 5ක් කියමු කරේ. රුපියල් 5ක් දීලා LED bulb එකක් ගත්තා. AA battery එකක් ගත්තා රුපියල් 30ක් හරි 40ක් හරි. කොහොම හරි අරගෙන එහෙම අරගෙන AA battery එකට LED එකක් ධන ඍණාග්‍ර වලට තියලා බලන්න. ධනාග්‍රය කියන්නේ මේකේ දිග එක. ඒකට වයර් එකක් දාලා ප්ලස් එකටත් ඍණාග්‍රය මේ පිටිපස්සෙන් තියෙන ඍණ එක එහෙම තියලා බලන්න පත්තු වෙන්නේ නැහැ. ලාවට පත්තු වෙනවා. යාන්තම් පත්තු. හේතුව මේක මදි. කරන්ට් එක මදි. පත්තු වෙන මේක ඇම්පියර් ගන්න කරන්ට් එක මදි. Okay, let's connect that to the coin battery. Coin battery is 3 volt, right? මේ 3 volt coin battery එකක්. එයාට connect කරලා බලන්න. Cathode to this edge and anode. ධනාග්‍රය අනිත් පැත්තට. Let's start the simulation, and you can see there's a problem. So මෙතන පොඩි මේකක් එනවා problem එකක්. ඒක මොකක්ද? Can you read this and identify what is the problem? Yes, Pute, come on.
High voltage.
Ampere, like not just voltage, it is getting 61.9 milliampere, whereas the bulb need only 20 milliampere. Right? You are getting more milliamperes. Then what is the risk when you are getting high ampere? It's high power, right? High power means like bulb can burn and there will be heat. So how to reduce this? Yes, less lifetime. How to reduce this? Yes, guys, you know. Electronics, then the resistor. You have to use a resistor. Let's use a resistor now. I'm going to delete this edge, and instead of that, I'm going to use a resistor. So you should know how to read the color code even, but for your examination, it will not be asked, right? So let's use resistor. This is 1 kilo ohm resistor, and I'm connecting this now to the positive edge. Let's simulate, and you can see now it's average light because 1 kilo ohm is like more than enough. Let's reduce that to 1 ohm. You can see it's also a problem, right? At least you need like 100 ohm maybe. Okay, now you can see it's cool. So when there is 100 ohm, something okay, 50 ohm, not enough. That is also not a big problem. 50 ohm is also enough. So 100 ohm is somewhat safe. So you can say, let's say 20 ohm, problematic. Still you are getting 28 milliampere. So I think V equal IR, you know the equation. V equal IR. If you increase the R, it will decrease I. Right? When you increase R, because keep the same voltage, it will decrease the I. Right? Let's increase the R and decrease the I. Put in 50 ohm or like even 100 ohm, 50 ohm will solve this problem. So this is basics of electronics. Okay. Any doubt up to this level? So once you connect, you have to play this, right? Start simulation. When you stop simulation, you cannot see the bulb. But when you start simulation, you can see the light of the bulb. Okay. Happy with your results or still unhappy? Come on, guys. Come on. Please talk. Need to be active. Shall we move to the next one? No feedback. Okay, I also remain silent. So when you see, when you have done, please let me know, then we can proceed.
Just still doing.
Sorry?
Still doing.
Okay, sir.
Okay, let's proceed. I'm going to delete this. I'm going to select and delete. Just select, click on that, and put delete button. It will delete the content. I don't need the LED, I don't need the fine battery and this battery. So let's remove it. So now, let's do some simulation. I need Arduino UNO board. Arduino UNO board. And this time what I'm going to do is I'm going to test this Arduino UNO board. So when there is a UNO board, there will be a USB. So that USB you have to connect it to the computer, and there's an application for Arduino. I think I don't have the application in my computer. So you can download this Arduino IDE. If you actually get this development board, then you can download this Arduino IDE from the arduino.cc website. It is free and open source. So therefore you can download. It's available for Mac OS, Linux, and also Windows. Just download it, and that will open an interface for you to code it. Actually, when you connect this board to the computer, your computer will allow to write to this EEPROM, electronical erasable, flash ROM. There's a flash ROM. So you can write to this flash ROM. This is a ROM, read-only memory, but you can flash it. You can reflash it. You can write the program to this IC. By writing program to this IC, we can change the program. Okay, let's see this. First of all, I would like to introduce LED, and I'm connecting the anode. Come on, you need to connect with Okay, let's do something like this. I'm going to connect anode with 3.3 voltage node. You can see here, let me zoom. This is 3.3 and where's my cathode? And please come here. And I'm going to ground the cathode. Ground the cathode. Once the power is given using USB and turn on the simulation, you can see bulb is blasting. Why? The reason is, you know the reason to it. So 3.3, that is too much. Right? You can see it's getting 206 milliamperes. 26 milliamperes. Then don't connect like this. So the simulation helps us. So let's use resistor. I'm connecting using a resistor. Resistor to this node and then this node to 3.3 volt. Okay, I'm happy. You can see it's not emitting that much of light and it's not burning even. And just turn on the LED using this. And I need like 500 ohm maybe. But 500 kilo ohm, I need 500 ohm. That is also too much, 200 ohm. Oh, it's 200 ohm. Even 100 will be okay. 100 ohm, let's use 100 ohm. Okay, now statistically, this is not a circuit, this is not a program. I need to write programs, I need to write coding. Therefore, I'm not connecting to the 5 volt. Instead of connecting this to 3.3 volt or 5 volt, I'm removing this edge and I'm connecting this to pin number 13. Here, pin number 13 and then ground. So one node to pin number one node to ground, the other node to pin number 13. Let's start the simulation and you can see a blinking bulb. Can you see that? The bulb is blinking. Can we see that or not? Yes,
Yes,
or
sir.
no? Yes.
Yes.
So have you done that? I would like if you can do this. Get the Arduino board, connect the ground, connect the anode to pin number 13 with 100 ohm resistor. And play the simulation. Okay, done.
Okay, sir.
Okay. Right. Then so let's do small program. Let's write small code. Let's go to the code and you can see this is block mode, right? Block mode coding. Block mode coding is for kids. For you, I think we can write the other way. So let's move to the other way, the coding. Coding, not the block mode. I need, I'll stop this. Here I'm going to change it to the text, right? Text mode coding. So what do you have to do? Click on the code, change the blocks to text and continue. Then you can see this C++ coding. Have you seen? Have you accessed this?
Yes, sir.
Yes. Okay, this is where you write the coding. Right, this is where you write the code input there, and you can see what can you do now. Basically, when you connect, this is the code that you see in your IDE, and I'm going to edit that. So you can see digital write LED built in to 13. So instead of this LED built in, I'm going to change this 13 to number 13. That is the pin number. Pin mode 13 output. I'm setting the 13th pin as output pin. Then I'm setting the 13th pin to high voltage and waiting 1000 milliseconds. That means 1 second. And then changing the 13th pin to low voltage and waiting for 1 millisecond. When I play this, you can see the 13th pin, it's giving here, giving high voltage, waiting 1 second, giving low voltage, waiting 1 second. So let's edit this. I just want to see, change that to 100. Let's stop the simulation and I'm going to change this to 100 milliseconds. 100 milliseconds means 1/10 of a second. So I'm changing to 100 milliseconds. I don't need to change the comment. These are comments, just explaining the code, right? No need to have the comments. So let's remove the comments. Let's play it. Now you can see my bulb is blinking rapidly. Can you see that? The speed is 1/10 now, 1/10 of second. 100 milliseconds of 100 milliseconds on. It is 1/10. Okay. Yes or no? If you cannot understand this, please let me know, then I'll explain again.
Sir, can you explain delay 100 part?
Delay 100 means you have to wait in this stage for 100 milliseconds. Otherwise, if you would just without, let me comment this. I'll make a comment karot. If I comment this, AI state එක ඉන්නේ නැහැ. On වෙලා ඉන්නේ නැහැ යම් වෙලාවක්. Off වෙලත් ඉන්නේ නැහැ. එතකොට on වෙලා ඉන්නෙත් නැහැ, off වෙලා ඉන්නෙත් නැහැ. If I run this, you can see always on hari, always off hari state එකක් තමයි. Always on වගේ තමයි පේන්නේ. මොකද on වෙලා ඒ state එකේ ඉන්නෙත් නැහැ, off වෙලා ඒ state එකේ ඉන්නෙත් නැහැ. එතකොට එහෙම දෙයක් පේන්නේ නැහැ අපිට. On වෙලා ඒක ඉන්න ඕන. Delay එකක් කියන්නේ නැවතිලා ඉන්න ඕන. You have to stop. On and stop for 100. Then on and stop for 100 විතරක් දුන්නොත් on වෙලාම ඉන්නවා. Off වෙන්නේ නැහැ. අයි off වෙලා හැටි off වුණ හැටි ආයේ මිලි තප්පරයක්වත් යන්න කලින් on වෙනවා. Understood?
Yes, sir.
I have to wait.
Seconds?
Sorry?
100 is in milliseconds.
100 in milliseconds. 100 millisecond is 1 divided by 10 seconds. 1000 millisecond is 1 second. Okay.
Okay, sir.
You can actually do this, right? To buy Arduino board, I think you can go to Dara's website and then buy this kit. If you really want to learn the programming using this board, just go and buy Arduino UNO board. Actually, if possible, the kit, entire kit. So Arduino UNO board, this kit, you can see it's only 1,700 rupees. That is for the kit. Just purchase that. It has Arduino board and some LED bulbs, resistors, some switches. Then you can start programming with that. The basic set, basic kit. Okay. So, you know, through Daras, you can just bring it and pay it, like cash on delivery services available with Daras. Right? Clear on this? I think this is a very good deal because board will cost 1,600. Here, board and some resistors and LEDs you can get even with a breadboard. Even at the breadboard, you can get for 1,700, means it's a good deal.
Yes.
Okay. So let's go here. Now you can see it's blinking. So what happened if I change the blinking speed to 10 milliseconds? What happened then? 10 milliseconds. Then what will happen? Yes. Can we see the turn on, turn off status? On වෙනවා off වෙනවා පේයිද අපිට?
No, sir.
Why? ඇයි පේන්නේ නැත්තේ?
Cannot
හේතුව
see clearly.
cannot see clearly. The reason is that our human eye keep light for some time. අපේ ඇහි ආලෝකය ටික වෙලාවක් තියෙනවා. දැන් බල්බ් එකක් දිහා කෙලින් බලන් ඉඳලා ඇස් පියාගන්න. So look at a bulb and close. Yes, close your eyes. That yes, that you can see that preview in the eye for some time. Right? So the speed is too high. So before, even though the light is off, still your eye will say, I will explain to brain that light is still on. Therefore, you cannot see the off status of this bulb because this is too fast. Now you cannot see the off status. You will practically see this. When you are doing this, you will practically see this in the... Now you can see this board is programmable. And so why? The programmable is not just to turn on a bulb. So let's say you have multiple bulbs even, you can do this, right? Let's say you have multiple bulbs. And my recommendation, if there are multiple bulbs, I recommend you to use, okay, let's hide the phone. Use a breadboard. Breadboard is a tool, or breadboard is a special equipment where the connectivity can be expanded. Here. So all these are connected. All these are also connected. These are connected. These are connected vertically. These are connected horizontally. These are vertically connected. These are horizontally connected. Therefore, I can connect some bulbs. Okay, let's connect some bulbs. And I'm going to connect this bulb to number 2. Another bulb is connecting to number 6. Another bulb connecting to number 10. Another bulb connecting to number 14. Now I have 4 bulbs. Okay, let's connect in another bulb. And that bulb I'm connecting to 18. Then the minus node, I'm just connecting to the minus, somewhere in the minus, somewhere in the minus, some in the minus, somewhere in the minus. Then I'm connecting my ground pin. I'm just connecting my ground pin to minus pin. Then all the bulbs are grounded. All the bulbs are grounded. Then what I'm going to do, I'm going to UNO board and connecting my 8th pin to this one, connecting the 9th pin. To this one. Yeah, I think better I drag this a little. Otherwise, like it's unclear, right? Okay. Let's drag it a little. This is pin number. Then pin number 10. Connecting to this one. Then pin number 11. connecting to this one, and then pin number 12. Okay, now you can see 12, 10, 12, 11, 10, 9, 8. These pins are connected to breadboards. So no resistors, don't worry about that. I think it won't burn. When you start, you cannot see anything because still we have not coded anything. Let's go to the code. And I just want to define, so set of pins. What are they? The 12th pin, 11th pin, 10th pin, 9th pin, and 8th pin as output. I'm coding. Define these pins as outputs. Okay, after that, I'm doing something like this. I'm turning on the 12th pin, and then I'm setting other pins. That means 11, 10, 9, 8. Those two low, right? Let's see what's going to happen. These are all these are low. This is also low, and I'll keep this for 100 seconds, 100 milliseconds. Copy and paste in the same. One more time. This time I'm keeping this low, but increasing this to high. Again, waiting. The next time, keeping both 12, 11 to low and 10 to high. Paste in another time. Again, low for 12, 11, and 10, and high for 9. Keep in 100 milliseconds. Then low to everything, but high to the 8. So what will happen? What will happen if I run this code? Come on, guys, you are doing O levels, A levels. Sorry, not O levels. First time the 12th pin is high, other pins are low. The next time 11 is high, other are low. 10 is high, others low. 9 high, others low. 8 high, others low. Then what will happen? Ah? Yes, I cannot hear you. Okay, let me show.
By bulb, it turns on and off, starting from 12.
Yes. Can you see this? Can you see this? It's nitride effect, right? So everything can be programmable. So now you can understand everything can be programmable to this board. So that the problematic icon comes because there are no resistors. That's the reason. So better you connect these two resistors. So let's connect negative edge resistor. And that resistor, let's keep it 100 ohms. Let's ground it. But still that won't work because you know the plus edge needs this is 1 ohm. It's not, sorry, it's my mistake. Now it's okay, right? Sorry. Plus or minus, okay, it should be okay, right? Now you can see smoothly it's transferring, right? Smoothly it's transferring the light. And you can speed up this. So let's speed up this. I want like 10 millisecond. I think it's not a very good thing, but still you can monitor because there are 5 minutes. 50 millisecond. So I think you can see that, right? Maybe like a bit faster. No, that is too fast. Can't see. So let's put 50 millisecond for each. Stop the simulation. 50 per each bulb. Otherwise, you will not be able to monitor this. Okay, this is creating Knight Rider kind of circuit, but only one way. You can create that both ways also, right? We can see moving light, a moving light. This is what you can do with the programming board, right? You can code, you can control, code and control. Okay, shall we create this? So I think you can create this at home, right? Practice this. So this is the code. In case if you need, so this is the code that I wrote. And this is the board. Code and board, both you can see. Okay. Take a snapshot and practice at home as a homework.
Sir,
Yes.
so Arduino to work, any OS is okay?
To Arduino to work.
It can work on any OS?
Yeah, it can only work on any OS. Windows, Linux, any OS can be. Okay, with this part.
Okay.
Right, let's start the simulation. And this time we are going to come up with another new project with a sensor. So I need to consider about a sensor module. Okay, let's see which sensor I'm going to use now. Okay, let's take a new one. I'm going to take a new project. Let's delete this. Okay, let's do this with me, Pute. What I'm going to do now, actually, I'm going to use PIR sensor, right? PIR sensor is basically that is what, so you have one project now. So I think PIR sensor would be ideal for this project. You can use ultrasonic also. But rather than using ultrasonic, let's move to the PIR sensor, it's easy. Okay, the circuit diagram you can see. So I'll give you time. Let's create the PIR sensor and the circuit diagram as this. So let it load. Okay, can you get PIR module? It's there. It's there in the bottom. If not, please search, right? Search as PIR, passive infrared sensor. PIR sensor. Then you can find this PIR sensor. And connect the passive infrared sensor. So there is the ground you have to connect to the ground. Then you have the signal node or the power node. Power node, please connect to 5 voltage. And then the signal node, please connect it to the pin number 9. Then small LED, I have connected that LED to pin number 7 and also grounded that. So please create this quickly. And then I'll teach you how to code and how to get a result from this. The behavior of PIR sensor. So how PIR sensor behaves? PIR sensor is basically passive infrared sensor. Passive infrared sensor. PIR means passive infrared. Means it's capturing the infrared signals from some object. Right? Let me simulate and see. The passive infrared sensor basically what it does, when a person is moving, the sensor will be activated. But the person is moving somewhere here, the sensor will not be activated. Person is moving somewhere here, the sensor will not be activated. The person is moving in a faraway place, again the sensor will not be activated. But in the activation zone, you can see the red color area, that is the activation zone. So when person is moving here, the sensor emits a signal, so basically 1. Logic gates. මේ sense එක 1 issue කරනවා 1 දෙනවා කවුරු හරි move වෙනවා නම් නිකන් ඉන්නව නන්නේ. මෙහෙම තනිය මෙහෙම කෙලින් හිටගෙන ඉන්නව නන්නේ. ඔයගොල්ලෝ දැකලා ඇති දොරවල් ඇරෙනවා. මිනිස්සු ළඟට යද්දී. හැබැයි මිනිස්සෙක් දැන් ඔය ඇරෙන දොරක් ළඟ සුපර් මාකට්ස් වල එහෙම තියෙන ඔටෝ ඇරෙන දොරවල්. sense කරලා ඔටෝ ඇරෙන දොරවල් තියෙනවා. ළඟට යද්දී දොර ඇරෙනවා. නැත්නම් ඔය hand blowers තියෙන hand blowers කියලා කියන්නේ මේ ඔයා වේලන්නේ hand dryers නේ hand dryers තියෙන. hand dryers තියෙනවා. ඒ hand dryers වැඩ කරන්නේ අත හෙලෙව්වම. නේද? දැකලා ඇති ඔයාලා. අත හොලවන්න නැතුව නිකන් අත නිකාම්ම තියාගෙන ඉඳලා hand dryer එක වැඩ කරන්නේ නැහැ. අත හෙලෙව්වම තමයි hand dryer එක වැඩ කරන්නේ. එතකොට ඔය hand dryers ඊළඟට මොනවාද මේ automatic doors ඔය ඔක්කොම වැඩ කරන විදිහක් තියෙනවා. ඒතර ඔය වැඩ කරන්නේ motion එකට. කවුරු හරි move වෙද්දී ඒක infrared source එකක් වෙන්න ඕන. මිනිස්සෙක් move වෙද්දී. භාණ්ඩයක් move වෙද්දී නෙවෙයි. කෙනෙක් කවුරු හරි මිනිස්සෙක් move වෙද්දී තමයි ඔක වැඩ කරන්නේ. සතෙකුටත් වැඩ කරනවා. මොකද රත්තු වස්තු වලින් infrared පිට වෙනවා. ඒ හින්දා මිනිස්සුන්ගෙනුත් infrared යනවා. ඒ infrared තමයි මෙයා capture කරන්නේ. මෙයා බලන්නේ මේ infrared change වෙනවද? passive infrared එකෙන් බලන්නේ infrared එක change වෙනවද? කියන්නේ මෙතනින් මේ පැත්තට කැපෙනවද මේ? මෙහෙම කැපෙනවද? මේ lines කැපෙනවද? change වෙනවා නම් එයා 1 දෙනවා. ඒ කියන්නේ ඇවිදින කෙනෙක් ඉන්නවා. move වෙන object එකක් ඉන්නවා. There is a moving object. That is what the passive infrared sensor is detecting. When a passive infrared sensor detected a moving object, it issues 1. When it issues 1, it will go to the board. And there is an input. This is signal node, no? So you have the ground is grounded. Then the power, you have to give 5 voltage to work. And the signal node, signal is issued in 1, and that 1 will be captured by pin number 9. Here, in the diagram, you can see pin number 9 is capturing that. Once it is captured as input, you have to define in the code. Code says pin number 9 is input. Pin number 7 is output. So when the value of pin number 9 is high, that means when you get some value to pin 1 hour in the logic gates. Remember the logic gate. Listen now. If the PIR sensor sends 1, if it is send 1, then what you are going to do? You are sending high voltage to pin number 7. So pin number 7 is connected to the LED and it's waiting 100 milliseconds, and after that it will off. If it is not giving that high voltage, that means no one is moving, then it will be lower. Here you can see LED is lower by default. You can just take the code, Pute. Take the snapshot of the code also, because you can try this. Okay, when somebody is moving, the pin number 9 says there is input. When pin number 9 says there's input, pin number 8 will get high voltage. With that, the bulb will turn on. When no one is moving, so pin number 9 is not giving any input. Therefore, pin number 7 will remain lower. So bulb will off. Understood how these logic gates are working now? This is actually the logic gate behaviors. Logic gate la api katha karanne. One unot mehemai, gindara pat unot mehemai, fire mehemai, if wind, if dry, if wet, if raining, if dark, if somebody is moving. So this is actually the implementation of those logic gates using the circuitries. I hope you understood the lesson, and this is how the IoT devices are working. These are programmable devices. These are programmable ICs. So have you seen the world's smallest computer? This is world's smallest computer. It is smaller than grain of rice. You can see this is rice seed. So this is the smallest computer. Here, grain of rice, the smallest computer. That is smaller than grain of rice. Means Chinese people are saying like this, Chinese engineers, they are telling garbage will be expensive than these chips, or these chips will be even less expensive than garbage. You can see the chip. This is not that chip. This is another chip. So this is the smallest computer chip which is put into rice or salt. You can see how small that is. So think about the devices that are going to come. Small computers will be like inserted into these devices. So this is smart ring. Smart ring means a ring. Ring is small device, but still it is connectable. It is connectable to the internet. Therefore, there are smart devices which can be connected to the world. So world will be connected, or Internet of Things, or Internet of Everything will be there in the world in near future. So now also that is IoT, but in future it will be IoET, Internet of Everything. Okay, that is the lesson. So it is easy lesson and we have done that. Next day we can start the e-business lesson. Okay, then see you all next week, Pute. Please do this, do the practicals and try to understand the lesson.
Sir,
Yes?
sir, what lesson is taught in 2023 class?
Sorry?
What lesson is taught in 2023 class?
2022?
2023 class.
2023. So we are teaching the Python lesson today. Okay. Right, then I'll stop from here. Good night. See you all next week, right? Bye.
Good night, sir. Thank you.
Thank you. Bye.